Hello everyone, welcome to this video session. My name is Ron Lee and I work as a solutions engineer at DJI Enterprise. Today's session will be covering DJI Terra software and more focusing on the photogrammetry process workflow. With that being said, let's get started. First thing first, you need to open up DJI Terra software. So we'll be using DJI Terra version 3.3. If you're using a newer version, the user interface will be slightly different, but workflow-wise, very similar. All right, so now we open up the DJI Terra software. You notice on the right side, we have a map viewer. And on the left side, we do have a list of the missions available. If you had previously reconstructed some missions or created some missions, whether it's a flight route mission or reconstruction mission, all these missions would be listed on the left side. Also notice we have two tabs available here. One is reconstruction, the other one is flight route, just to separate the pre-planned flight missions versus the reconstruction missions. So make sure you're under reconstruction missions. And we actually just flown a set of data we would like to do some photogrammetry process with. So I'm gonna select a new mission on the bottom. Of course, make sure you're under reconstruction tab. And I'm gonna select the visible light. And what visible light means is just photogrammetry missions, whether you want to output a digital automodic map, or you want to output a 3D model representation or a point cloud. This will be the option to select. Okay, over here, you do want to rename your mission name. For example, I'm just gonna name it demo. This would give your project a quick name. Once you import the name of the project, the next step will be adding some data. So over on the right side, as you notice, the left list disappeared and the map viewer moved to the left, and now we have more detailed settings on the right side for the reconstruction missions. Usually you'll have a pretty good experience just walking from top to the bottom, just from what we just did, renaming the project, to add data, to adjust the position data of the images, then aerial triangulation process, then the actual reconstruction process, then some annotation and measurement if needed. So always work from top to the bottom. So we just named our project. Now we just need to add some photos. Now you can select add photo over here to add individual photos, or you can select add folder to add a folder which contains all the photos you need for processing. Well, in this case, I will just be using add folder because DJI Pilot software actually organize all the photos into the folder I need. So for example, over here, I have a data set available. And this one specifically is for DJI P1. It's captured by DJI P1. So I'm just gonna select this folder, which contains all the photos available. Over here, you can select multiple folders if needed. So DJI P1, for example, would actually separate or create an additional folder when the original folder contains over 1,000 photos. So it's going to create a different folder. But again, you can select the multiple folder if you want to. For this one, I'm just going to select, actually I'll select both. So on the bottom, you see it's adding all the photos. Okay, that's pretty quick. Yeah, this process should be very quick once you select all the photos. As you can see now, we have 1,152 photos available, and I can click on it, which it actually shows me all the photos available. I can modify individual ones. For example, I can highlight this one and I can see this is where the photo is located, highlighted as an orange. This is interesting because on the map layer, the geozone is kind of blocking the view. So if you want, you can choose to hide the geozone just to have a cleaner map to work with. Also, if you want to, you can select the satellite view if that makes everything easier for you. Let's select the back to map, just it's easier to see. Okay, for example, I highlighted this one, which it would show up on the actual map. This is all the photos apparently apparently we just imported, and each individual photos will be shown as a little white dot. So we actually have an option for user to select if you, for example, want to just process this section. Okay, and it would actually only select the photos contained within this sections. So it gives me options to delete photos within selected box or just keep the photos inside the selection box and delete photos outside the selection box. This is something we can do, which I'm not going to be doing that. So I can select all, I can delete all, and this is a lot of options you can do. Since we imported all the photos from two folders, as you can see now, this is organized by two lists as well. So this one has 1,000 photos, and this one only has 153 photos. Okay, now once we imported the photos and filter out all the photos we don't need, we can start working on the post data. So post data is necessary when you're trying to do post-process kinematic work and you already have a better or corrected position of your original photo from the PPK calculation. If you're flying under RTK network or RTK method, overall, this is not required. However, if you are flying under GPS, you want to correct your position using PPK methods, you will need to write that corrected post data into all the photos. So DJI Terra software actually does not do PPK calculation, but it does import and it would override. It does have a feature to override the image post data. So for example, over here, I have 1,000 photos, for example. I can select this button to view all the post data. Now this shows, of course, longitude, latitude, altitude, which is the post data. It will also show me the horizontal accuracy and vertical accuracy. As you can see now, these accuracies are within 0.03 and 0.06. Now the unit is in meter, so this is 3 meter and 6, 3 centimeters and 6 centimeters correspondingly. And because I captured this data using DJI P1 system under RTK network, so DJI Terra software automatically knows that information. So when I'm importing the data, the horizontal accuracy is automatically set to 0.03 meters and 0.06 meter for vertical accuracy. But if you're using like other drones, for example, or other systems, this could be default to meter level. So this is something you need to modify individually, along with the longitude, latitude, along with the corrected longitude, latitude, altitude values. So over here, just to show you, we have an edit option over here. Select that, and you can add that post information by selecting here. Select the add post data. That's going to bring up a window for you to select the post data for the images. And over here, you can define if you want to separate each column by period or comma, if you want to. You can also select a separator for decimal. And once you define the latitude, longitude, and altitude, as well as the photo name count, you can override to the existing photos. Now, if you're using a PPK software solution which already writes these information into photos, you don't need to do this again. This is just for a data set which does not have the position corrected yet. Of course, you can define the post data coordinate system as well over here. Okay, so we're using RTK. We don't need to do this for now. And moving next option, it will be the Aero Triangulations. So under Aero Triangulation, we have scene and we have computation method. We also have advanced settings. So let's talk about scene first. So when you check the scene options, we have three. One is normal and the other one is circle and power lines. So for the most scenario, we will just be using normal. Circle and power lines are two scenes we optimize in DJI Terra software to output better results. So circle is more focusing on the vertical structure, which users captured using orbiting methods. For example, cell tower will be one great example for using the circle. And for power line, for example, transmission lines, we'll use this scene. What difference it made is really the team did some optimization work to make the results look better. So when you're, for example, reconstructing the power lines using a different scenes, you could lose some details like the actual transmission line, but selecting power line would help improve the results. So other than the circle and power lines, we would recommend users just to use normal for the default scene. Next one will be the computation method. So this one only applies to the cluster version of DJI Terra. So if you're not using a cluster version of Terra, you can just select the standalone computation, which uses your machine to process the model or the results. Under Aero Triangulations, you also find advanced setting. Advanced setting over here would give you GCP management options for user to add GCPs or checkpoints. Also, you have an option to output the Aero Triangulation model in XML format if needed. Once you selected the output format, it asks you to define the coordinate system for the output. But for the most cases, I would just leave this off. And for the GCP management, if you select this option, it's gonna open up a different window. Excuse me, it's gonna jump to a different session for managing the GCP and adding the GCPs. But before we do that, we do have a feature point density option as well over here. So right now we only have two. This basically is for users to select if they want high point density Aero Triangulation models, or if they want to do a low point cloud density transmission models. So by selecting or changing these options would change the speed of the process. Of course, if you select low point density, the triangulation model would process faster. When you select high, it's going to take longer, but honestly, not that long. Aero triangulation process is a fairly quick process, so we recommend to leave it as high. What's the reason for having a setting here is because if user, for example, is working on some texture, is pretty plain, doesn't have much features. For example, if you're only mapping out field and it doesn't have vertical structure differences, the texture looks like the same. If that's the case, we would recommend to probably select high. And if you have a lot of feature or texture differences, maybe select to low. Okay, that way you have enough points to work with for the GCPs and others. But as I said, recommend to leave it as a high because it doesn't take that long. Okay, now go to the GCP management. So once I clicked on GCP management, it's gonna change from the map viewer to a 3D space viewer. Now over here you see all the positions of all the photos I just imported, as well as their orientation. If you zoom in closely, you also see the direction of the flight. So you see this triangle that indicates it's flying this way, and over there it's over flying this way. Anyway, but it doesn't give me any points right now. Something we can do over here is to import some GCPs if you have some. Over here, before you import GCPs, again, work from top to the bottom. The first one will be defining the coordinates system of the GCPs. For example, over here, this one specifically, I know I captured the GCPs under WGS84. I will select the WGS84 if you want, or if you're using different coordinate system, which is very likely, you would select the search over here. And over here, you will need to import your EPSG code to define which projection system you're using for logging all these GCP points. And altitude settings over here, we have default. Default is ellipsoid height based on the model 12A. And we also have absolute height, or the EGM 96 height, EGM 2008, along with others. Once you define the coordinate system, you will need to add GCPs. Now we can select import mark file or import GCP files. So that's identical, but one is for mark, one is for GCPs. We just do GCP for the demo purpose. Before I select anything, we also have add GCP and delete GCP. This is just individually, manually adding these GCP by importing the longitude, latitude, or northing, easting based on the system you're working with. Which actually I will be adding GCPs through a file, so that way it's easier. So right now, this is my GCP files. The format is CSV, and if I open this up as Excel file, you can kind of see how it's labeled. So the first column over here, that is just the name of the GCP. Second one and third one, second one and third one being the actual coordinate, and the fourth one being the height. This is the ellipsoid height as I defined previously. So once I selected this file and save all the points available, I can just save it as a CSV and I can just import it in Terra. So I'm going to select the CSV file and select the open. So a message will show up importing GCP successfully, and you will be able to see all the GCPs here available in kind of, over here available. All right, excuse me a second. Okay, you can kind of see the 3 points I just imported are shown here. If you cannot find the points, sorry about that, 1 second. All right, if you cannot find these points shown on the 3D viewer, one thing you can do real quick is to check if the coordinate system is correct or not. You might have selected a different coordinate system. That's why these points can be way off and not showing up on the viewer. But once you imported and successfully imported these files into the system, as you can see, when I tap on one of them, it actually highlights all the photos which contains that point. Similar to other photo image process software, you can filter out photos only with the GCPs. Okay, that filters out all the photos only with GCP. As you can see now, I have only 20 photos to work with. And you also see marked 0. That means I have marked 0 GCPs. So over here, all you need to do is to do some markings, just like other photogrammetry software. You select the 1 GCPs, and you want to filter out all the photos only contains GCPs and select the first photos. As you can see right now, I have some, it's off by a little bit. All I need to do is to make sure I mark the center of my target. That's going to leave a green cross over here. The blue cross over here, that just indicates the position where you estimate it to be. Usually it would not be this far. The reason it's kind of far because of the elevation is not yet calculated. If I do the aerial triangulation work, then I do the marking. That will be easier. So what we recommend user to do is, before actually marking any points, we would recommend user to do aerial triangulation first. Otherwise, they might have a hard time finding some GCPs. So since I have processed this data before, I can kind of bring up that GCP management. Okay, so since I have marked this one before, as you can see right now, once you marked everything, these crosses, the green cross as well as the blue cross should be together. So since this one looks like this one, I have processed it, so I cannot really modify it. Otherwise, I will have to process it again. So let's go back to the one we created under GCP management. So let's just start with this. But again, we do recommend to Aero Triangulation first, then do the marking. Okay, this one is for demo. I'm not gonna do the Aero Triangulation because it will take a while. So you need to do the same thing, and as you can see, as long as I mark the second point, the blue cross is already closer. Okay, for example, here it's pretty off. Mark it. We recommend just to mark 5 points, 3 to 5 points each. If you can, mark them all. Mark just 3 or 5 each. So you're gonna do all of these for all these points, essentially. And once you finish, you actually be able to see the reprojection arrow and corresponding 3D point arrow in meters. Now you're seeing 4 meters off because, again, it's because I haven't done the Aero Triangulation. If you've done the Aero Triangulation first, then marking all the points, you have a better results. And this area we're working on right now is relatively flat also. If I bring up the process, the one I can show you under GCP over here, you can see this surface is pretty flat, and so definitely do Aero Triangulation first before you marking all the points. Otherwise, you may even have some points missed from the photo library. Okay, once you've finished marking on these points, let's go back. You would like to do optimize. So at that point, you already finished Aero Triangulation process. Once you mark all the points, you will need to select the optimize. Once you select the optimize, essentially it's going to optimize that Aero Triangulation results, and it's going to improve the accuracy of the model globally. So this one I have already finished, and I can bring up the Aero Triangulation report. This one option will show up once you finish processing the Aero Triangulation. Okay, so opening this up and select Chrome View. Just open it under the Chrome, and so you can see right now it gives me a Terra quality report. So you see the RTK status, you see the image information overview. This is the amount of photos we imported, and this is the RTK status. RTK status, so the software would read individual photos, and the individual photos contain its own RTK status. So from our system, from the DJI system, the DJI Terra reads these information automatically. So fixed is under corrected. So when you're under fixed, you're centimeter level, and floating is decimeter level. Single is meter. Other is not correcting with RTK at all. So as you can see right now, it's all RTK fixed. That means it's all good with the data. Moving forward, it will also give me the camera calibration information, and which includes all the detailed less distortion parameters information over here available. So once you're finished with the Aero Triangulation process, you can start working on the actual reconstruction. So once you finish the Aero reconstruction process, on the bottom, if you want to generate a model of the scene, you will select 3D model. If you want to generate a GeoTIFF map, as well as the GeoTIFF digital surface model of the scene, you will select 2D map. Okay, so let's do the 2D map. So the 2D map, when you open up the option, you will have resolution available. So we have high, medium, and low as the resolution available. Again, for the scenes, this is for the 2D map reconstruction. The scene, we have field, urban, and fruit tree. For now, we always recommend user using urban. Always recommend user using urban. The field and fruit trees are more using for agriculture applications. So similarly for the computation methods, we have cluster. Again, this is only for the cluster version of DJI Terra. So for our users, we would use, for other users, we will use standalone computation. Under advanced, so this is the settings available to adjust the region of interest. So in order for user to select the region of interest, I think it's better for me to, sorry, 1 second. Just to demo this, I'm gonna create a new mission. And for this one, I would be just using view photos, just so I can speed up that process. Oops, I think I accidentally select, okay. Okay, I'm just gonna do 11 photos for this one, and I will do the Aero Triangulation real quick. And sure, let's do high for the point cloud density. Okay, so this is gonna do the Aero Triangulation really quick. I feel like that's easier since we have the models or something to work with. Okay, this is just Aero Triangulation results or point cloud for these 11 photos we just imported. And under 2D map, back to where we at. Of course, you can select back to 2D if you want to. That's easier to see. Under 2D map, under advanced, back to where we were talking about, the region of interest, when you select this option, first of all, the Aero Triangulation results will pop up. And this function actually would require user to finish the aerial reconstruction first. Aerial triangulation reconstruction first. So over here, you need to, what it does, region of interest, what it does is it defines the region for the export, for the final deliverable output. So if you are mapping a region and you have boundary, then you can select your boundary over here. You can select to import the KML to define the area, or you can manually define it by selecting some points. This is similar to mapping, for example. And I'm just going to create 4 points. So as you can see right now, every single point contained within this region or this box, this yellow box, it's going to be kept, and everything else will be excluded from the actual deliverable. So this is the interest region essentially. So over here you can, oops, you do that. Delete this one real quick. You can select apply to apply that area, and you can max out the region if you want to, and select the smart mode that essentially would keep a boundary or the general area of the model. But usually if you don't define anything, or if you don't define the region at all, we will just do, if you don't need to define the region at all, we just leave it as it is, not doing anything. So this is the region of interest. Let me exit out the Okay, back to where we at. So for output coordinate system, now this just defines, again, just like the ground control point, this defines the output coordinate system. So if you want your output map to be under WGS84, you can do that. Or if you want to do it under different coordinate system, for example, NAD, or others, you can certainly do that. Simply just search, again, EPSG number or EPSG code to quickly identify and locate which system you're using. Altitude as well, as we covered. Map grid, this is something user can select to enable. It also has a little description over here. So DOM and DSM will be divided into grids if map grids are enabled. So for some third-party softwares, ArcGIS and other softwares, other GIS software mostly, they're having issue. They will be having issue when you're importing a map 10 gigabytes big, and that's just sometimes it's hard for these softwares to handle. So that way we create options to crop your original map into individual ones, smaller ones. That way you can import them into these softwares easier. So you can define the pixels for your grid or smaller maps. From 5,000, for example, the default is at 5,000. So when you select this, it's going to create multiple 5,000 by 5,000 little maps. So for you to import individually into third-party software, if that makes everything easier. So that's 2D. Once you define everything, you can start reconstruction. And once you finish reconstruction with 2D, for example, first of all, the 2D map will show up on the map viewer, so you're able to check some details quickly. And you're also able to do some quick measurements if needed. This is some measurement tool we were talking about. So upper here, we have quick measurement tool available. So if you want to mark like a point over here, you can just tap on it. It gives you the northing and easting value available. Also, you can, if you want to do a quick measurement of the length, you can do that as well. Something like that. Okay. You also be able to measure the area, of course. Similar concept. Okay. All right. But this map would overlay on the map viewer. If you want to close it, you can choose to close it. Also, if you don't want to see it on the map. Once you finish processing the map, how do you access the actual map? Is to go back to reconstruction list, select the open folder over here, and it's gonna quickly open up a window over here, and it's under map folder. Okay, and you will find the result.tiff. So this is the actual map in GeoTIFF format. If you want to see the digital surface model, this is here as well, named as DSM, format also TIF. Okay. So that's basically it for the 2D mapping. So for the 3D model, actually, it's slightly different in terms of a workflow. Let me go back to the one I was working on. Yeah, this one. All right. So for the 3D model over here, similarly, you have resolution settings, high, medium, low, and scene over here available similarly. You also have computation method. Yep, this is exactly the same. You also define the region. Yep. Over here, the difference is the output format. Now we have point cloud available as well as the meshed model available. So you have to click on the format you want to export. We support multiple formats at a time. So if you want both LAS and PLY out, or both PLY, or both PLY and OBJ out, you can do that. So Terra is going to generate the same model essentially, but in different formats. But essentially, when you select the multiple formats, for example, this one, I have it all selected. When you go back to the list again, select open folder. Now, not under map folder, but under models folder. If you open this up, it's gonna open up, and you're gonna see a PC folder. You just open up the PC folder under 0 folder. You'll be able to see all these formats listed below. Okay. For example, I want to check the LAS. Now just open up the LAS. Now I'm able to see the LAS file of the LAS point cloud for this model. This is how you access the deliverable data.